In this video, I am going to give you an introduction of normal distributions. A normal distribution, also called a Gaussian distribution, is a symmetric and bell-shaped probability distribution. It is a continuous probability distribution that is widely used in statistical analysis and modeling. The density curve of a normal distribution is called the normal curve. As I explained in a previous video, there are two properties we need to check for the density curve. The first one, density curve must be on or above the horizontal axis. It is true here. The second one, the area under the curve must be 1. Yes, here total area is 1. The normal curve never touches the x-axis as it extends away from the mean. Yes, the normal curve never come to the x-axis but getting closer but never touch it. The curve of a normal distribution is determined by two parameters, the mean mu and the standard deviation sigma. When we use x as a random variable, you see here horizontal axis, it says x, those are the x values. So then we can say x has normal distribution with mean mu and the standard deviation sigma. A normal distribution can have any mean. That means mean mu can be any value from negative infinity to positive infinity. It can be negative number or positive number. And any positive standard deviation, but the standard deviation must be positive. We know this is a symmetric distribution. As we discussed before, any symmetric distribution, the mean, median and mode are all equal. Yes, it is the same here. The mean, median and mode are all equal and located at the center of the distribution. It is the same for any symmetric distribution. Location is determined by the mean mu. When the mean of a normal density curve changes, the curve moves along the horizontal axis. Let me explain this. Here, this is a normal curve and x is the random variable, mean is 4 and sigma can be any value. So I keep sigma fixed, so I change mean. This one mean is 4 and I change it to the negative one. Yes, you see what happened? It moved along the horizontal axis. Then I change this mu and keep the sigma same. I change the mu to the 10. Then it moves to your right side. So therefore the mean is called the location parameter. How about the sigma? Yes, spread is determined by the standard deviation sigma. As the standard deviation increases, the bell-shaped curve becomes flatter and wider. And as it decreases, the curve becomes taller and narrower. Let me show you here. Here I keep the same mean and change the sigma. This one sigma is 2 and I change it to 0.5. You see what happened to the curve. And I change again to 8. Yes, now you understand what happened to the curve when we change mu and sigma. Then inflection points. Curve change shape at the inflection points. The two inflection points occur one standard deviation away from the mean. What is the meaning of this? Yes, this is a density curve of a normal distribution with mean mu and the standard deviation sigma. According to definition of the inflection point, you can calculate the sigma and mu plus sigma and mu minus sigma, then draw the vertical lines, then the point that meet vertical line and the curve are the inflection points. Now let me explain an example to understand this concept. Here you have a density curve, normal distribution. Then can you tell me what the mean is? You see the middle value here between 3 and 4. Therefore mean should be 3.5. Then how do we find the sigma, standard deviation, when inflection points are given? Yes, what are the inflection points here? They are 2 and 5. Then how do we find the sigma? You can get the sigma 5 minus 3.5, that is 1.5. Also you can consider other inflection points too. Then what do we do? 3.5 minus 2, it is also 1.5. Okay, how about this? What is the mean? Mean is 6. And what are the inflection points here? They are 4 and 8. So what is the standard deviation? You can say 8 minus 6, that is 2, or you can calculate sigma by 6 minus 4 is also 2. Now you understand the mean gives the location of the line of symmetry and the standard deviation describes the spread of the data. Let me give you another example. Which curve has the greater mean? Yes, there are two curves A and B. The line of symmetry of curve A occurs at x equal 5. The line of symmetry of curve B occurs at x equal 9. Therefore, curve B has the greater mean. Right, second one. Which curve has the greater standard deviation? Yes, according to the concept I explained, curve B is more spread out than curve A. So, curve B has the greater standard deviation. In my next video, I am going to discuss the 68, 95, 99.7 rule, or we can say empirical rule.